In this lesson, we will perfect our understanding of transformation of quadratic functions and associated changes in the graph. Let's consider solving the given example. Here the given function is f of x equal to minus x plus 2 square minus 7 by 4. We can rewrite this function in this way: minus x minus 2 square plus minus 7 by 4. That makes our comparison with the standard form just easier. F of x, and now comparing with f of x equal to a into x minus h whole square plus k. And here you can see that the value of k is minus 7 by 4 and the value for h is minus 2 and the value of a is minus 1. So here vertex is equal to minus 2, which was originally equal to hk, is now equal to minus 2 and minus 7 by 4. Minus 7 by 4. In terms of decimals, this can be written as minus 2 minus 1.75. And the vertical stretch factor, vertical stretch is a, which is equal to minus 1 in this case. Now we will get started to draw the graph of the given function. But the graph of given function is just similar to the graph of the base function y is equal to x squared. We have only transformation that we need to apply. So let's find out where the vertex is. The vertex is minus 2 minus 1.75, and that's right here. Vertex v is minus 2 and minus 1.75. Now, if we carefully look at the changes in the values of y for the base function, we have a pattern. We have a pattern for changes in values of y for f of x equal to x squared, and that pattern is equal to 1, 3, 5, 7. And if we want to find out what is pattern for changes in value of y for the current function, so pattern of changes in the value in the y values of given function can be obtained by only multiplying a with 1, 3, 5, and 7. And since a is equal to -1, so we place -1 time 1, 3, 5, 7, and now we can multiply, and this pattern will become -1, -3, -5, and -7. So let's get started with changing these values of y for every left or right one step in change for x. So one step from starting from the vertex v, one step right and one step down, we end up here. So we are done with this part for one step down. Again, one step right and 3 steps down. So one step right and 1, 2, and 3. That's where we are. 3 steps down. This is the new point. And now one step right and 5 steps down. So one step right and 1, 2, 3, 4, and 5 steps, we end up here. Similarly, we will find points on the left side. One step left, one step down will be right here. And one step left and 3 steps down, one step left and 1, 2, and 3, we will be right here. And then one step left and 5 steps down. So this we have applied. So now one step left and 5 steps down. So 1, 2, 3, 4, and 5. We end up here. Now we have enough points to draw the graph of this parabola, and we can draw this graph like this. This may not be the best curve, but at least it will show the trend in the values. So this is how we can this is graph of the parabola, and this graph has the corresponding function f of x equal to minus x plus 2 whole square minus 7 by 4. This is the graph of the given function. And we already found what the vertex is. We can similarly find other properties like axis of parabola. Number 2, axis of parabola. Just put the square term equal to 0. The square term is minus x plus 2 whole square equal to 0. So this will give us x plus 2 equal to 0, means we have x equal to minus 2, which is axis of symmetry or axis of parabola. The vertex is already, we have found minus 2 minus 1.75. Number 3. Graph is facing downward, so there is maximum point. Since graph opens up or faces downward, so maximum point. So maximum is equal to y value of the vertex, that is minus 1.75. And if we want to find out the focus, number 4, for finding focus, first we'll need to find out what the focal length is. So let's find out focal length. Focal length, that is equal to 1 by 4 of a value, and that value is 1, ignoring the sign, so this will be 1 by 4 times 1 is equal to 1 by 4. Remember that length is never negative, therefore you have to ignore the negative sign if you are considering the focal length. And number 5 is the focus. Focus is equal to whatever the x value of the vertex is, because it's going to be right here. So this would be minus 2, and then minus 1.75 minus focal length, that is equal to minus 1 by 4, and this will be equal to minus 2 minus 1.75 minus 0.25. That will make it complete, and this will become minus 2 and minus 2. So that will become the focus. And number 6, directrix. Directrix will be above the parabola, and that will be y equal to y value of the vertex, which is minus 1.75 minus 1.75, and we will add the focal length, that will be plus 0.25, and this time this will be equal to minus 1.50. So this means y plus 3 by 2 or 1.50, whatever, is the directrix. Number 7, we have already discussed what the axes of symmetry are. So what is left behind is the equation of lattice rectum, equation of lattice rectum. This is a straight line joining 2 points of parabola, just passing through the, this is the length of lattice rectum, this is LR, and this is the directrix. That is, lattice rectum and directrix are equidistant from the focus of the parabola. So equation of lattice rectum would be equal to y equal to 1 point. So that would be minus, what was this, was directrix. So this would be equal to y coordinate of the vertex will be minus 1.75 minus 0.25. In other words, this is equal to y is equal to y coordinate of the focus. So this would be equal to minus 2. Y is equal to minus 2. and length of lattice rectum is 4 times the focal length. So 8 length of lattice rectum is equal to 4 times focal length, and since the focal length is equal to 1 by 4, so this is equal to 1. That's all for the properties of the parabola or for the elements of the graph, and we'll see you in next video.